9.4 partial fractions. So the point of partial fractions is to turn something like this into something like this, where we're calling decomposing, where find a way to split up these two factors in the bottom so that they each have their own fraction. This is important when you get a calculus, where dealing with this is difficult, but when you deal with two separate parts, it's not as hard. So this is how you do it. So if I have 3x, x plus 2, x minus 1 on the bottom. So it's two parts on the bottom. That means that I'm going to have two sets of fraction. Okay, so pretend that this is not over here. This is not. That's the answer. But pretend you don't know that. So we have two parts. The first part is x plus 2. Second part is x minus 1. And then there's going to be a number on top. I don't know what that number is. So I'm going to call it a. There's going to be a number on the other side. I call that b. So the goal is to find what a and b are, so that we have a decomposition. So naturally, when you see fractions, you want to get rid of fractions. So I need to multiply the top and the bottom, or both sides, by x plus 2, x plus 1, whatever's on the bottom, x minus 1. I need to do that at both sides. So on the left side, it's pretty simple. That goes away, and it does that every single time. On the right side, so this is a two-part thing. So the first part is we are going to multiply just this one with these two, and you'll see that this and this are gone. So I have a, x minus 1. And then if I multiply this with this again, now these two are gone. So I have b, x plus 2. So really, you could do, if that's confusing, what's happening is this multiplies this one, and then also multiplies that one. So you get to here. Again, naturally, you want to distribute. So I get 3x is equal to ax minus a plus bx plus 2b. And then we want to combine like terms. They don't look like terms, but they are, because they both have an x. So I have a x plus bx minus a plus 2b. And then the last thing I need to do here is I need to factor out an x. So a plus b. So normally you guys are comfortable writing it that way, where you take out the x, but I'm going to leave the x in the back. You'll see why. So when you have this set up like this, what you can say is 3 is equal to a plus b. The reason you can say that, imagine if you have something like this. Let's say 4x plus 10 is equal to ax plus b. If you have something like that, since these both have an x, you can say that 4 is equal to a, and 10 is equal to b, because they both don't have an x. Okay, that's the only way that's going to work if they're equivalent to each other. So here, since they both have an x, I can therefore say that 3 is a plus b. And then 0 is equal to negative a plus 2b. The 0 came from the fact that you can always have a 0 behind anything, right? So therefore, this is equal to that. This is equal to that. So now you have a system of equations. If I add these, 3 plus 0 is 3. That goes away. And then I got 3b. divide by 3 to both sides, and I have that b is equal to 1. Once I know that b is equal to 1, I can plug it in here. And then a is equal to 2. So to finish off this problem, you have to replace the a and the b there. So your answer is 2 over x plus 2 plus 1 over x minus 1. Okay, so that's a partial fraction decomposition. There is a faster way to do this, but this faster way only works sometimes. So imagine we have this. So, and this comes from, you need to be a little creative to figure this out. So I can let x equal 1. The reason why I'm choosing 1, and you can choose any number you want, but the reason I'm choosing 1 is if x is equal to 1, what you will see happen is this one is a times 0, therefore a is no longer there. So this is 3 is equal to b times 1 plus 2, that's 3b. So b is equal to 1. So I got my answer quickly. I can also let x equals negative 2, because if this was negative 2, then now this one is gone, because that creates a 0 there. So I have negative 3a is equal to negative 6, therefore a is equal to 2. Right? So that's a fast way to find it, but you got to be kind of creative to see that. So get the next one. So I'm going to factor the bottom. Don't worry about the top. I'm going to factor the bottom. The bottom can be factored into this. And that could be factored more into this. And then one more could be rewritten as this. Okay, so that's my bottom factor. So I'm going to go ahead and erase the rest. So the bottom is factored into that. On the top stays the same. So the tricky part with this one is that I have 3 of them, because you have 3 pieces down here. You have an x, you have an x minus 2. And so you can't say x minus 2 again, because if you have that, then these 2 fractions are actually just 1. So this is actually a power of 2. And then you have your a, b, c. So put it down here just so I have more space. I'm going to multiply the bottom, or get rid of the bottom by multiplying the bottom. Do that on both sides. So that goes away. I have a negative x squared plus 2x plus 4 left over. On the right side, if I focus on this one and this one right now, you will see that the x's go away. So then have a times x minus 2 squared. If I do the b now, this will cross out with one of these. So I get b x minus 2. And now if I do the c times this and that are gone. So I only have a plus cx left. Okay, so you got to take them one individually at a time. And as you do this more, you'll start to see patterns popping up. So this one, you can use that trick that we just saw. It's a fast trick, but that trick will not work for every single letter. So I'll show you what happens. So I can let x equals 2. If x is equal to 2 and I put a 2 there and a 2 here, and also a 2 there and a 2 there, you're going to see that this knocks out, this knocks out. So I have negative 4 plus 4 plus 4 is equal to, and I'm also going to put a 2 there, 2c, and then you're going to see that c is equal to 2. Okay, fast way, right? But again, that doesn't always work. Another way, or another number, if I let x equal to 0. So the idea of this is if you choose a number and you can get rid of the other letters and only have one letter left, then you're good to go. So if I let x equal 0, you'll see that B is going to be gone, C is going to be gone. I put a 0 there and a 0 there, so I get 4 is equal to a negative 2 squared, which is 4 is equal to 8. 4a, a is equal to 1. So to find b, there is no number that you can choose for x that will give you b, right? Because there's no number that you can choose that will knock out the a and the c at the same time. So for b, you're going to have to do the traditional way. So let's say I have this. I'm going to distribute. So before I do that, I know that this is x squared minus 4x plus 4. So then I have ax squared minus 4ax plus 4a. Over here, I have bx squared minus 2b x. And I have my plus cx. Combine like terms. So I can put these two together. I can put this one, and this one together because they all have an x. And then the 4a is by itself. So I have ax squared plus bx squared. And then I have a minus 4ax plus 2bx plus cx. And then I have my 4a with no one to be paired with. And then I can factor our x squared here. I can factor our x from these three. Let's do a plus negative 4ax, or negative 4a plus 2b plus cx, then plus 4a. So you can actually, if you're comfortable, you can go from this step straight to that step. You can skip that intermediate middle step if you want. If you need to write that middle step, that's fine too. So now that I have this, if I use what we did earlier, I can compare. X squared is right there. Therefore, negative 1 is equal to that. And I don't need to compare the rest. I don't need to compare this one and this one. I can, but you don't need to because I know what A and C are. I know that A is equal to 1. So I have a negative 1 is equal to 1 plus B. And therefore B is equal to negative 2. And then make sure you plug him back in. So here's my answer. A is 1, C is 2, B is negative 2. So that's my answer. And then the last one. So this one is tricky. So I have two chunks. X plus 3. X squared plus X plus 2. So on the top, it's going to be A. On this side, it's going to be BX plus C. So the BX plus C, the point is the power is 1 less. The power is 2 on the bottom, so on the top you need a power 1. And if you have a power 1, then you have a number after it. So the idea is over here you can have a 0x plus 8. But, I mean, that's, you don't need to write that. So that's where that BX plus C comes from. Okay. So just like before, so on the left side, I still have my 8x squared plus 12x minus 20. And really, if you're comfortable, you can skip this step also. So if I multiply the bottom to both of them, if I multiply the bottom to both of them, I get A, x squared plus x plus 2, and then I get bx plus c with the x plus 3. If you're not sure how I did that, if I multiply this to the bottom, that will cross out. So then I have my A left over, I have this left over. And then I do that to this one. This will cross out with that. And then I have my bx plus c left over, my x plus 3 left over. That's how I did it. So here, naturally, you can't use a trick that we did earlier. Actually, you can, if you choose x to be minus 3. So again, and that comes with seeing this enough and understanding what's going on. So you can let x equals negative 3. So if every x becomes negative 3, I get this. I get 8 negative 3 squared plus 12 negative 3 minus 20. That is equal to A negative 3 squared plus negative 3 plus 2. And then here, if I put a negative 3 here, this creates a 0. Therefore, that whole chunk is gone. So, on the left side, let's see, this is 9, so that's 72, minus 36, minus 20. That's 16. On the right side, this is 9 minus 1, that's 8, 8a. Therefore, a is equal to 2. So now if I want to find, so I know A is. So you can use the traditional way of redistributing everything and comparing if you want. You can also just plug in A for 2 if you want. So there's a couple ways to do this. So what I'm going to do, I'm going to substitute 2 for A because I know what that is. Okay. And then now I'm going to do my whole distribution and everything. So I get 2x squared plus 2x plus 4. And then I'm also going to distribute all of this. So I get bx squared plus 3bx plus cx plus 3c. And this is equal to that. Let's do some combined like terms. I could put these two together because they have an x squared. I could put these together because they have an x. So I have 2x squared plus bx squared. And then, I'm going to do this quick where I can take out a x squared. I have 2x plus 3bx plus cx. And that becomes, if I take out an x, 2 plus 3b plus cx. And then I have plus 4 plus 3c with nothing there. So I can do my comparison now. 8 has to be that. 12 has to be that. And negative 20 has to be that. So if 8 is equal to 2 plus b, therefore b is equal to 6. I have 12 is equal to 2 plus 3b plus c, but I know that b is 6. So I have 12 is equal to 2 plus 18 plus c. Or actually, here's an easier one. Negative 20 is equal to 4 plus 3c. So I have a negative 24 is equal to 3c. C is equal to negative 8. So I have my A, my B, my C. Now, make sure you plug them into here, here, and here. So my answer is 2 plus 6x minus 8.